The principal concept within Rhea's project was the notion of the occupied bridge. She took the opportunity to recall the old-time bridge, which was built in the medieval period to connect Newcastle to Gateshead. This type of structure is a special architectural condition. It draws together the contrasting worlds of water and land. Rhea recognised the importance of drawing together the landscapes either side of the river. In effect, she looked to connect two worlds together that share the river, but are completely independent and have their own identity and characteristics. Rhea looked at how an occupied bridge could serve to reinforce the place characteristics, as well as defining a new territory as a third space. To develop the conceptualization of her project, Rhea referred to the writings of the German philosopher Martin Heidegger, where he explains how the bridge is not just a functional object, but also a place and a connective device. Rhea researched similar aquatic facilities to her proposal for Newburn. The best examples exist in Scandinavia, especially in Norway. The Institute of Marine Research in Bergen is the largest marine science community in the country. It provides research into the aquaculture and ecosystems within the coastal regions. Precedent in architecture is the analysis of past buildings to inspire and inform new work. Rhea considered the industrial forms within the vicinity of the site to derive her material and architectural language. She principally used precedent in terms of establishing her programme and the layout of her building. She was also inspired by the work of the modernist architects Ryder and Yates. This practice gained an international reputation in the 1960s and 70s for their taut modernist forms. Rhea built a physical model to explore the skin. She also developed the section and initial attitudes to technology. The skin treatment was perhaps too universal, so she then built new models that concentrated on language, particularly in relation to the treatment of the skin. As the concept design evolved through a combination of hand drawing, physical and computer modelling, Rhea updated the Vasari model. She worked within 3D and plan views to ensure accuracy within the model. Rhea was now exploring how openings within the elevations would affect the internal environmental conditions. She then created openings within the mass model to simulate potential window sizes and orientation. Once the proposed openings were modelled, Rhea added floors to ensure Vasari could more accurately calculate internal spaces and volumes. The model was now ready to evaluate solar radiation. She inputted proposed sun details and the type of study required, which in this instance was a 1-year solar study. The model was then updated to illustrate graphically which parts of the facade received the highest levels of solar radiation, which in this case was clearly the highly glazed elevation to the west. To compensate for this, Rhea introduced vertical solar shading to evaluate the effect this would have on the glazed openings. The updated model and solar evaluation showed how the level of solar gain could be controlled through the introduction of shading devices. She then used the wind tunnel function within the climate analysis toolset to evaluate what effect the proposed structure would have within the vicinity. She quickly realized that the schedule of accommodation was not equally sized between the 3 blocks, with the visitor centre being much smaller than the research and teaching buildings. Also, the building user having to travel between the different blocks across external gantries was problematic.
Something that kind of moved with the river, it could kind of start to, it might be a dynamic form. And again, there's precedent in the northeast for that as well, because you've got the transporter bridges, that go across the Tees. And there used to be, all along the town, there used to be ways of bringing kind of bricks and things across the, on pulleys. So there's a lot of precedent for these sort of structures. So that might be something very interesting to sort of see whether the whole building moves.
Yeah.
Like a dynamic piece of landscape. You know?
Yeah.
So that might be worth something. But I think at the minute, the thing I would probably say that's absent is perhaps its sides. You know, so I just wonder whether there's kind of something that you want to kind of have, you know, if you have got this thing that kind of hovers over the river, whether there's something which you could kind of, I like the way it's slung underneath, but perhaps something that starts to kind of move and then might even engage with the structures on either side would be very interesting.
Yeah.
And you know, because it's going to have to be pretty substantial. It's going to tie in well with the kind of structures you get on the Tyne. You know, the big, you know, the ferry terminals and the big kind of pieces of steel, that kind of the gantries and stuff that you see with big industry.
Yeah.
I think that could be a really nice tie-in. And then you might, you know, that view down the river is significantly different to that view.
Yeah. So just treating the facades very differently.
And it may be that this is where the college is for the marine.
Putting some